Now we're going to configure authentication between router 1, ASA 1, and router 2, and we're going to use, for this example, MD5 authentication. Now remember, RIP can do both plain text authentication as well as MD5, but for purposes of this example, we're just going to configure it with MD5, and for the most part, you're going to understand how you would configure it if you were to use plain text authentication. A couple things that are a little different between the router and the ASA. With the router, you're going to create a keychain, and then you're going to apply that keychain to the interface when you enable authentication. With the ASA, you're simply going to configure the authentication key on the interface. So let's start out on router 1. We can see in the topology here, we've got the information that highlights the authentication key is going to be $C!$C0. So let's go ahead and go configure that. And here we are on router 1. So we're going to create the keychain first. We'll call this RIP key. Show you the question mark here. So the first thing we're going to do is configure a key ID. And you see we have to give it a number. We've got quite a few numbers that we can use there, but we're going to give it key 1, and then we're going to define the key string. So we said that was an uppercase C, an exclamation mark, dollar symbol, a C, and then a 0. So basically it looks like Cisco. Okay, so now I can exit out of here and exit out of here. And I can go into interface F0/0. There's no need to enable RIP authentication for F01 because if we look at that interface, F01 is our connection back to the server. Our server's not running RIP. We could actually make that a passive interface if we wanted, so that it'll advertise it, but it will not send updates out that interface. We'll go ahead and add that in here in just a little bit. But let's begin with the authentication on our F0/0 interface. We're going to use the IP-RIP authentication command. And now when we look at the question mark here, you got two options: define the keychain or set the mode. So we can say that the mode in this case is going to be MD5. We'll hit enter there. We can use our up arrow and we can take out a little bit of that, save us some typing. And if we say keychain, it now wants the name of that keychain, which we called RIP key. Okay, so no additional options there. We enable it. And now we've got RIP authentication enabled for the F0/0 interface. Now let's go ahead and go into router RIP and let's do the passive interface fast Ethernet 0/1 just to clean that configuration up just a little bit there. And let's do a show IP route. Okay, so we still have some routes in our routing table that are coming from router 2. Now remember, these are sent periodically. The route's just going to get older and older, and eventually it's going to time out because we're not going to authenticate. Do a debug IP RIP, and then we have some options: events, trigger, database. We're just going to hit enter here for our debug IP RIP, and we'll let that run. Okay, so we can see we're building an entry and we're sending a v2 update. And now look at this. We see that we have ignored a v2 packet from 10.13. That's our ASA, and the reason for that, invalid authentication. Now there's another invalid authentication coming from router 2. So even though those routes are still in the routing table, they're going to time out, and that's because we're not going to accept the new updates because we have authentication configured. Let's go on over here to router 2 and let's configure the keychain there as well. So there's our keychain RIP key. Key 1 has a key string of Cisco, but it's spelled funny. We're going to want interface F00 for this as well. We'll look at the interfaces here and you can see that F00 is where our 172.16.10 is. So do IP RIP authentication mode. We're going to set it to MD5. Set the keychain to RIP key. And now if we go back over here to router 1, you can see we're ignoring .13. And here comes a valid update inbound from router 2. And so there's all those loopback addresses, and we received a packet, it's got MD5 authentication, and we're good there. Okay, so now let's go over to our ASA1. So here we are on our ASA. Go into interface VLAN 10. We're going to use the RIP command because we don't use the IP prefix on the ASA. RIP authentication. Our mode is going to be MD5. And RIP authentication key. And then we're going to go ahead and put in the key we'll use for this key string here. And then we'll say key ID is 1. So we've configured that MD5 key. We wouldn't need a key ID if we were using plain text authentication, but in this case we do. Let's go on back over here to R1, and let's see what R1 comes up with when ASA1, which is right there, sends an update. So we can see it received that packet with MD5 authentication, 192.168.45.0. So that looks good. So let's turn off our debug here, and let's do a show IP route. Okay, and we have a database, of course, that's full, a routing table that is full. We've got those 5 loopbacks that are being advertised by R2, and we also have the 198 address, the 198.51 that we're directly connected to. We have the 192.168.45 that's coming to us from RIP, and we don't see any 172.16 networks in RIP because we are directly connected to that network as well. Let's go ahead and come over here to router 2 and show IP route. And we can see that we do have the 198 network in our routing table. We have the 192 network in our routing table. And then we have all the loopbacks that we're directly connected to. Let's see if router 2 can reach our server. And of course we can. We've got a full routing table. And then finally, let's go ahead and do a show route on the ASA. And we've got our 198 advertised from RIP and all of our loopbacks 101 through 105 advertised. So that's our basic configuration of RIP authentication using MD5.